Hi folks, welcome back. So this is going to be our second of our little lessons for the Poisson distribution. So, and it'll just be on a similar theme, but there's always a twist as we go through things. So, let's see if it's going to play. Are you going to play, computer? I think so. There you go. So we're getting all sciencey here. So just give you a little bit of time to take that in, read my writing. So seen as an average, the mean number of bacteria in 1 milliliter of liquid, and they're saying that mean is known to be 4. Okay, so they're also saying that they believe that the bacteria is Poisson distributed, if it's a Poisson model. So they want you to determine the probability that there will be. So we need a question. No bacteria, basically, in the 1 milliliter of liquid. And do we have another question? I think we do. Oh, and we can just about see it there. Scroll down there. Let's see, go ahead. Three or more bacteria in the liquid. The 1 milliliters of liquid. Right, okay. I think we've got that there. Right, so the first one, A, no bacteria. No means 0. So this looks like an exactly question. And the second one, 3 or more, right? As soon as you have that or, and you know there's going to be many calculations. So let's just tackle part A. So we saw there that the mean for both parts is going to be the same. It's going to be 4. And no bacteria means for us 0, so that's why I'm just showing you x equals 0. Okay, an exactly question. Let's go for it. There's your formula. Okay, we've seen it many times in the last little video in class or remotely. So let's just plug things in. So the probability of 0 here. Put my numbers in again. Mu 4 appears twice, and 0 or x value, it appears only once. So I've just plugged that in, and it's just fired that number out. So, and I keep stressing, always double check your answers, and I probably should have bracketed up the top there. Okay. And don't just divide by 0, it's 0 factorial. 0 factorial is actually 1. Right. Trust your calculator. Right. So here, I've rounded up again, and so rounded it up to 0.02, which is 2%. But like I keep saying, you can put down that 0.01832 or all the decimal digits in your calculator. It's up to you. It's just by probability, because the answers lie between 0 and 1. Sometimes it's good to have a lot of digits in your answer in case you're adding like more than 1. Right, so what we're saying here is that there would be an approximate chance of 2% that there would be no bacteria in that 1 millimeter of liquid. That's what we're saying here. Right, so that was part A, an exactly question. Part B, okay. Part B, they wanted to know that it would be 3 or more bacteria in a 1 milliliter of liquid. So that's why I'm using the notation greater than or equal to 3. So we must include 3 here. So so more than or equal to 3. So how many would that be? Well, 3 itself, and 4, and 5, and 6, and 7, and 8, and dot, 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 whatever that means. Well, with Poisson distributions, well, they're saying there's an infinite number of probabilities, but see, in reality, there's not. But for us here, we just don't know the upper limit. Okay, we don't know it. Right, so we've seen this scenario before in binomial, that we're going to get around this, having to calculate all those probabilities. Yeah, I just contradicted myself. Yeah, they're saying there's an infinite amount. There's not really. It's just there's an unknown upper limit. And infinity is just a concept, okay? It's not a definite place, right, or number. So let's go on. Right, so what we're saying, use the fact that P of 0 plus, so that's probability of 0, probability of 1, 2, 3, 4, plus, dot, 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 right? Well, all the probabilities within a given scenario, like tossing a coin, heads or tails, half and half, add up to 1. Rolling a die, 6 faces, the probability of getting any one of the faces is a 6. Add up them, you always get 1. So here, like I said, in any given scenario, the sum of the probabilities is always 1. Never less than, never more than, always 1. So, that part there, probability of 3 plus probability of 4 plus dot, 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 that's what we want to calculate. Okay, that's what I had on another page. So that was a probability bacteria is more than or equal to 3. See those other 3 probabilities on the left, 0, 1 and 2, right? We don't have them. That there is a probability bacteria being less than 3, because 2 is less than 3, 1 is less than 3, and 0 is less than 3. Okay, so that's what we've got there, folks. Okay, so those two, they must add up to give me 1. That's a definite. So the one we want is greater than or equal to 3. So we're just going to get rid of the left-hand side, kind of highlighted with a curly bracket in blue. So I'm going to get rid of it. I'm going to take it to the other side and subtract it from 1. Okay? Because the b less than 3, it only contains 3 probabilities that I have to evaluate. So I'm going to take this on to another page here, and just to show you there. So 1 minus p less than 3 is 0, 1 and 2. So I've just put that in a little bracket there. So there's only 3 probabilities I have to work out here. So I'm just giving myself a little more space here. So it's going to be 1 minus, okay, and let's put them in with 0, 1 and 2 in place of x. And just remember that my mean was 4 here. Okay, that's the first one. Second one, the third one, with my x of 1, of 0, 1 and 2, with the mean 4 remaining the same. So just take your time with those calculations there. And when I put them in, I've always been working to 5 decimal places here because I found that seems to be manageable. I don't want to get any cruder than that until I get to the end of a question. And then I might round it up a little bit more just to get a handle on the number. Okay, so that's my 3 values here. Okay, so I need to sum them together. Done that, and then subtract it from 1. So 0.76. It is between 0 and 1, so it looks okay. And so what does that mean to us? Approximately 0.76, which is exactly 76%. So I'm going to make a little statement here. Let's see. Yep, and well, we can't always fit it in the one page. The more you write, the more the page just elongates itself. So there would be approximately a 76% chance of, I should have put in 3 or more there, but I'm actually saying it to you now. Approximate chance of 3 or more bacteria being present in 1 milliliter of liquid. Right, okay, so again, to start with, we had an exactly question, and then this one here, we had a more than, a greater than, or equal to. Well, I just want to go back a little bit. Don't want that. Let's just go back. So it's just to remind you, this come up before, okay? So our probability of greater than or equal to 3, there seem to be a vast amount of probabilities. So we get round that by using something that I've referred to before, and it was called the complement. So b less than 3 and b greater than or equal to 3, they complement each other. So they always add up to give you 1 there. So because there was fewer probabilities in the b less than 3, that's why I went for it. So that is an example of the complement rule. Okay, so the fewer probabilities you have, go for that. Okay, right. I'm fine with that. We've seen it. Right, I'm just going to go in here and just want to show you. This is one that I've actually taken from the notes here. Okay, some plumber, so they're on duty, on call. Here, average 5 emergency calls, so that's the mean. The mean is 5. So what's the question? What is the probability that we called out exactly 6 times in one night? Exactly. We like those questions. They're referring to this as part A. I'm only covering part A. I'll let you do part B from the notes that are on your Teams channel. And for anybody else on YouTube who's watching this, if you're lost in the middle of the night for some reason watching this, you won't have a Teams channel. So, exactly, we like those questions. So, our mean is 5, and our exactly 6 is our x. So, I'm just going to go for that there. There's my formula again, standard. My mean is 5, and it's exactly 6. Going for that there. Again, fire your numbers in. 5 and 6. So exactly 6, probability of 6. Numbers in, and I probably have bracketed the top here. Oh, I didn't. I should have done. Right. And as long as you put that in the calculator, it should be fine. So just put it in there. So the probability 0.14622, and knowing me, I'm probably going to round it again to 0.15 just to give me a better handle on it, which is exactly 15%. So for our plumber, our emergency plumber on call out, there's a probability that they are actually going to get called out of approximately 15%, 6 times per night. I should have put 15% there. But it is the 0.14622. And I think I'm going to stop that one there. And then I might go on to the last part in another video, and we'll see how we go on from there. Yep, I'll go for that.